Okay, so I'm going to go over properties of functions. Pretty much a function f from the domain x to the target or a range y is considered to be one-to-one, or they also consider it to be called injective. If x1 is not equal to x2, that implies that the function evaluated x1 is not equal to the function evaluated of x of 2. That is, f maps different elements in x to different elements in y. So later on, we will show you when we cover inverses how to prove if a function is considered one-to-one. It's coming up in a little bit. And so what we use when we do that is called contrapositive. So I will show you all how to do proof by contrapositive to prove that it is one-to-one. The function f mapped from x to y is considered to be onto. Another name for that is called surjective. If the range of f is equal to the target of y, that is, for every y element of set y, there is an x element of x such that f of x is equal to y. So the properties of being one-to-one or onto are important in many situations. Consider a function that maps employees to offices. So if the function is one-to-one, then no one has to share an office. If the function is onto, then there are no empty offices in the company space. So the company space is well utilized. So functions are used to define an assignment or processes to computers in a distributed network. So if a function is one-to-one, then no computer is time sharing between different tasks. Thus, if the function is onto, then all the resources of the network are being utilized. So let's take a look at a bijective uh, function that's considered to be bijective. So a bijective means that the function is both one-to-one and onto. So if those two are met, then we can do things to the function, which is the next section, which is inverses. So a bijective function is called bijection. A bijection is also called one-to-one correspondence. And so below are some examples that illustrate what a one-to-one and onto function looks like. So here's an activity below. Let's start it up. I have a function x with elements w, x, y, z. That's my domain. I have my target A, which contains the elements A, B, C, D, E. As you guys notice, W, X, Y, Z, they all have they're all being mapped. They're all utilized. So it is one-to-one. Wait a minute, it's not. F is not one-to-one because, oh, look at that. It looks like W and Z get mapped to a same number. So it is not one-to-one, right? So yeah, it's got each of these domain values must match to a different target value. So this does not, so that is not one-to-one. All right. F is not onto because no elements in X. Notice that in order for it to be onto, all of the targets values must be used up. But in this case, it does not. D and E did not get mapped. Therefore, it is not onto. So one-to-one means each of these domain values are supposed to get mapped to a different target value, and it doesn't. And all of the target values do not have a mapping from the domain. So because D and E didn't get used. So there's that one. Now, if we were to move the W and map it to D, now it is considered one-to-one because W goes to D, X goes to B, Y goes to A, Z goes to C. So all of my domain values get mapped to a different value in the target. So that's considered one-to-one. However, it is not onto because the E did not get mapped. Okay, so that's the difference. If we map, we actually we eliminate the E, then it is both 1-to-1 and onto. All of my domain values get mapped to a different target value. All of my target values have gotten mapped, so it is both 1-to-1 and onto, thus meaning it is bijection. Okay. All right, so let's take a look at some of the exercises below. Indicate whether the function defined below are considered to be 1-to-1, onto, neither, or both. Now, be careful and make sure that you understand the the rules set forth for the functions, especially when you have something like where it says you have the mapping from integers to integers. Sometimes they don't have any signs on them, so thus you're supposed to consider both negatives and positives. Sometimes you may have a negative, sometimes you may have a plus. If you have a plus or minus, if you have a plus, that means that you're only considering the integers that are positive. If it's negative, only the integers that are negative. Sometimes you may have functions that have fractions in them. If you have a variable in the denominator, make sure it may have, and it should have, a domain restriction. So you don't want the function to have undefined, right? So make sure that you understand and you know that sometimes restrictions are applied to some of these functions. All right, so let's look at this one. Is this one considered 1-to-1 and onto? Let's see. Let's figure it out. Let's check it out. So, hey Bob,
Hey, Pop, how you doing?
how you doing? You all done?
Yeah, I'm just leaving this house right now.
Oh wow, man, you guys were there for a long time. Who was helping?
Four other people, five other people.
My goodness, he must have had a lot of stuff.
So we moved stuff from his old bedroom and his shed.
Shed? He had a shed? My gosh.
Yeah.
Huh. Well, cool. You got to
And,
meet
yeah,
Monday?
and there was rat droppings, so that was fun.
Ah, nice. Rat droppings. You don't see that often.
Yeah, that was fun.
Well, you got to meet friends, huh?
Yeah, I got to get closer to them. Actually.
Cool, cool. Any females there or just all guys?
Yeah, there's some females. There's three girls actually.
Oh, you get to meet them? Now they're good friends with you now?
Yeah,
Are they
I
friends with you?
talked to them a little bit, made them laugh a little bit.
Cool. All right, Dad. Awesome. You get to connect.
And they like my truck because I brought my truck over.
Nice. Oh, yeah. Glad you got to meet with your friends today. You feel better?
Yeah, I need to get out of here, right? Because I mean, I'm just staying my home.
Yeah. Good. Now you get out. Uh-huh. All right, nice. Well, that was nice. And what was your friend's name?
Josh.
Josh, awesome. What does he play?
Yeah, he's remote.
Oh, nice. Oh, good, good, good. All right. Well, I'm glad you got to connect with them. Ah, now you get to go home and relax.
Take a shower first, and I'll do my homework.
Yeah, you have a lot of homework due tomorrow or just do Friday?
It's due Monday.
Oh, okay. Is it for discrete?
Yeah, it's easy.
Okay.
Functions.
Okay. Okay. Cool. 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 If ever you need my videos, I can share my videos with you. I'm going over properties of functions.
Okay.
Yeah. So they're nice. I'm dressed up nice. I'm dressed up nice. I'm wearing pajamas. So cool. Yeah, I was like, Jacob hasn't called me. Oh no, I feel alone. was working on stuff too. I was doing my grading. So I caught up on my grading. I'm just doing my videos. And then,
Oh, nice.
yep. And then I don't think I'm gonna do two tonight. And then oh that topic that we covered, oh, it was so tough, dude. We did a transitive and we did an example and they were questioning it. That's good. They were questioning why things were the way they are, and so I had to explain. And so it was pretty good. We got it through. We got through. So
Yes, sir. Yes,
yes,
sir.
sir. Man. So you're heading home? You're heading to the apartment? To the dorm?
Yeah.
Okay. Are you driving or no?
Yeah, I'm driving. I'm cool.
Oh, okay, okay. Is it far away?
No, it was close to the campus.
Oh, okay, okay. Cool. That's nice, Bob. That's nice.
His house is much nicer than the one he was living at. It was gross. There's like lint everywhere, hair, rat droppings.
Oh my God, it's a house?
Yeah.
Wow. So he has a house? Is he renting it or he bought it or what?
I don't know. I mean, he has a wife. Get her ready. He has a little baby girl.
Oh, okay. Well, yeah, you were helping him and his wife move. That makes sense. Wow, you moved everything today?
No, not everything.
Oh, okay.
But we moved like the majority of everything.
Okay, so everything's good. He can do the rest?
Yeah.
Okay.
Well, more people are gonna help. I can't because I have my half class.
Yeah, yeah, that's fine. At least you help up. I bet he's appreciative for that.
Yeah, I think it was. Yeah.
Yep. That's good, Bob. That's good. Well, good. You're gonna
Yeah,
go.
I'm
Uh-huh.
glad I bought my truck.
Yeah, that's good. About your truck, you're helping with in your truck. You put some stuff in it.
Uh-huh.
Awesome, awesome. And no one else has a car?
Some people had vans. My friend Josh had a truck.
Oh
He had
wow.
like a little he had a little trailer in the back too. So
Oh wow.
yeah,
That's
we moved
cool.
like some big stuff like this dresser, cabinets.
Oh, okay.
It was like a gift from his grandparents.
Wow.
So we were very careful with that. We didn't want to break it.
Yeah, that's valuable, dude. Super
They had
valuable.
like glass, like a mirror, glass mirror.
Oh, okay. Interesting,
Kind of
Bob.
like you guys have.
Oh
In the
yeah.
bedroom.
I like the bedroom? Yeah. That's cool, Bob. That's cool. Guess what I'm drinking right now?
A beer.
Yes, what kind?
Coors Banquet.
Yes! That's right. Good. It's good. It's good.
Sorry. Yeah.
So I'm gonna save you some, so you'll be all right.
What do you? No, no, drink it, Bob. Drink it.
Well, I need it for this topic here.
Oh yeah, there's a party Friday. No, so it's good secret. So it's only the band people know. But I'll go and I'll just drink only one beer. That's it.
Oh yeah. When is it? Friday?
Yeah, but I'll if I like it, I'll stay. But if I don't like it, I'll head out.
Yeah, go. Yeah, go, Dad. Just go experience it. Just just one time. Just go see what it's all about.
And I'm not gonna accept anything. Like if only I'll only get like a drink if it's closed. Like open the bottle.
Right, 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 right.
Sorry.
What happened?
And these people just came out of nowhere, dude.
You almost hit him?
No, I didn't hit them. They just came out of nowhere. They didn't see my truck or something.
I
Like,
know, but you almost hit him?
well, I mean, almost. I mean, they should have seen my truck. They should have stopped.
Were they walking?
Yeah, they had headphones in. I'm like, really?
Oh
Dude?
shit, Dad. Sorry. Man.
It's fine, Bob. It was my fault. Well, my fault. But whatever. But my truck didn't let me know it either. It didn't like beep.
Oh, they just cut in front?
Yeah.
Oh god. And it was red or green or what was it?
No, yeah, it was red actually. Yeah.
Oh, it was red and you went?
No. I'm at the dorm. The dorm.
Oh, at the dorm. Oh, you're at the dorm.
Yeah, there was like a little crosswalk by
Oh,
the building. They didn't see my truck. I'm like, really? Yeah, I stopped. So
yeah.
I
Okay.
didn't hit him. Thank you.
Okay. Okay. But
I'm good,
were
I'm good.
but they were all cussing at you?
No, I said I'm sorry. They said they apologized to you. They waved their hands. Like, sorry.
Oh, okay, okay. Ah, sorry, Pops. Sorry.
That's fine.
Oh, goodness.
My friend Josh was drinking Modelo. I was like, hey, you got an extra one? I'm 21. He's like, sorry, man, this is the last one.
Oh, well, I'm no friend of yours no more. I'm kidding. I'm
Shit's fun.
kidding. I'm kidding, Bob. You gonna go eat something right now?
No, I'm full already. They gave me pizza.
Oh, okay, okay. Awesome. Did you find parking?
Yeah, I do.
Nice. All right, Dad. Well, you're meeting friends. That's awesome. So you had a good day, huh?
I did.
You ready for tomorrow?
Yeah, so yeah, sorry. Yeah, I'm ready for tomorrow. Yeah.
What are we gonna say? What are we gonna say?
Oh, yeah, I was learning about all my friends. So they're in the like trombone choir, right?
Trombone
And
choir? What the heck is that?
it's like ensemble for only trombones.
Hmm. Interesting.
And the friends that won, they skipped the class.
What?
And today the teacher sent out a message saying that he was upset because not that many people were there.
Oh my gosh, man. I bet he was pissed.
Yeah. Oh, and today there was another volleyball game today, but no trombones were there.
No, no.
There's only one guy. One guy was there playing trombone.
Oh man, you could have gone, right? If you hadn't helped, right? Or nah.
I'll go to the basketball games. The volleyball games are just boring.
Really? If only you could meet the girls. That would be cool.
Yeah, totally.
Man, if only you could just meet the girls. Hey girls, what's up? I'm your boner. I'm your boner.
Some people have seven. And I saw her. She was pretty good.
Is
Number
she?
seven.
Number seven? What is her name?
I don't know what her name is.
Oh no, hopefully she's not from Czechoslovakia or somewhere around there. Oh man. Or she has a deeper voice than Juan. Hey, what's up? Ay, ay, ay. Yeah. Well, let Soretta loose out today.
Oh,
She was all
yeah.
happy. She was happy. Yeah, it's
Yeah,
supposed to rain. Huh?
Josh has a dog. Josh has a dog too.
Really?
Yeah, I was talking. I met her. She's cute. She's sweet. She's all loving.
Oh. Did you talk about Sorella?
Yeah, and then I showed her the picture. Like, oh, it's a cute dog.
Oh.
I told her she was a bark. She just barks in Japanese.
Yeah.
Or that laugh.
Don't laugh the nice. Yes, sir. That's how you do it. That's how you do it.
So where did you see before? I didn't mean to cut you off. Sorry.
No, what? About what, Bob?
The rain.
Oh, yeah, it's gonna rain tonight and tomorrow. So we'll
Yeah, it's gonna
see.
thunder. It's gonna rain Saturday and Sunday here, I think.
Really? Yikes. Yeah.
Kai's not gonna be here this week. He's gonna go visit it. Okay, so he's having trouble with his computer. He has a MacBook like me.
Uh-huh.
Yeah, and every time you close the lid, it turns it off.
What? Did he drop it accidentally?
No, he didn't do anything with it. He thinks maybe because he had it in his bag and he had it in his cup of coffee, his like thermos of coffee. He thinks maybe condensation maybe seeped into it or something.
Or
But when
or
he
yeah.
or it's a defect, because like when he went to Best Buy, they said, I mean, yeah, they can't find anything wrong with it. The only thing they can say is the battery's defect.
Hmm. He didn't put like
So
he didn't put maybe like a magnet. You know, like sometimes there's a magnet that you put in your bag. There could be a magnet in his bag and it messed it up. Something.
maybe I don't know, but yeah, he's gonna go to Dallas to the Apple store, and they're gonna give him a new one,
Oh, okay. Okay.
and then he's gonna go visit his parents.
Okay. Cool. Cool.
So I'm just gonna be me
You'll be by
alone.
yourself. Well, you get to go to the party, and then you're not gonna meet with your little group on Saturday.
No.
The honors, what do you call it? The honor little group. But
No.
you go to a party.
Yeah, they said I already went to enough events to be in the nominated in the to be picked.
Oh, really? You already picked?
No, they said I already went to enough rush events to be like to go to like the big event.
Oh, okay. So what is,
Which is a potluck.
oh, what does that mean?
Potluck you can bring food.
Oh, okay. So you can go in? So you're in it. You're in it then.
Well, not in it. I have to go to the potluck and then they'll tell me if I'm in or not.
Oh, okay. Okay. You're gonna go to it?
Yeah, I'll do it.
So, yeah, all right.
I'll pay the
Awesome.
fee $290 to get in.
Sure. Sure. Wow. Did you know y'all have a Texas Tech soccer team?
Uh-huh.
They're cute.
All the girls?
Yeah.
Ooh, I'll have to check it out.
Should I send you the picture?
Sure.
Okay, let's see. Screenshot.
I don't know.
Screenshot. Too bad you guys y'all don't play for the soccer team.
I know, we should do that. We have a
Okay,
soccer thing.
save. Let me see. Let me see. Where's the camera? I do have enough storage. Storage. Were you able to talk to mom yesterday?
Yeah, I did.
Oh, okay, okay.
She's doing alright. She had to stay till 2:30 a.m.
Yeah, jeez.
Oh, mom, golly. She needs to get out of that place, man. I don't know why she stayed at St. Philip, and she was talking about her hours. She had like her boss is making them like be at the map world. They have to stay there, and if they're not, then they get their paycheck deducted. That's stupid.
Yep. Yep.
And golly, man, it's getting to a point where there's someone in power controlling how much you get paid.
Yep. Yep.
Golly, that's all right.
That is
Uh-uh.
it's stupid though. Did you see that your cousin got a house?
Which cousin?
Isaiah?
Oh, really?
Yeah, he bought a house. I don't know, he bought a house or his dad got a house, and I don't know if it's like used or fixed up or I don't know what. Like he's gonna have to be responsible. He's gonna have to pay the bills, the electricity, the taxes, the insurance. He's got a lot. It's not just the house you're gonna buy. You're gonna buy a whole bunch of other crap. Oh, goodness. I don't know if he's working that well. Where is he working at? Anyways, that's just him. I mean, more right. Texas. Let me see. Texas Tech.
So
Uh-huh.
yeah, here's my idea. So first, I'm gonna go get an apartment, and then I'll get an apartment and maybe move to like we'll see first to see if I move in with one of my friends at his house that he's renting. And maybe down the line, if I get a job, I'll go to like an apartment, move into like an apartment. And if I get a girlfriend, me and her stay together. And if we get married, then we'll stay there for a while. And if we have a baby, we'll take care of her, him, her.
Oh, whoa. Calm down, sir. Calm down, sir.
Once we have like enough money invested, then I'll see if there's like a safe, like a quiet little place, like kind of like where we live, but like we still have like a little bit of more neighbors, right?
Yeah.
And I also want the house like built from scratch. I don't want it unused, like used. I want it like built from scratch.
Yes. So you can put the basement. You can put the drugs. You can put drugs in there. I'm kidding.
One zone.
Wine cellar. You can put your Coors Light. All right, here I'm sending you the picture of the volleyball players. There you go. All right, let me see. I see your number 7. Her name is Macy. Macy? What? Her name is Macy Jacob.
Macy's.
Macy's. I'm glad. No. Woo-hoo-hoo-hoo. Oh. Woo-hoo-hoo-hoo. Yeah, her name is Macy Mathis. She's a freshman.
Really?
There's a Davila. Interesting. Yep. All right. Cookies? Cookie? Oh yeah, they have all the bios on them.
Oh, really?
Dang. I'll send you the link. Macy Mathis. Oh yeah, she's cute. She's from Bulverde, Texas. She went to Smithson Valley.
Really?
Yep. But she's from Anglo. Maddie Korea. Elena. Here, I'll send you the link. Hold on. I'll
If
send
I'm
you.
gonna have to call you back because my phone's about to run out of battery.
Okay, man, I'll be here.
Okay, let me go to my dorm and I'll call you back.
Yeah, juice it up and then just call me at 10:30. That way you can fully juice up.
Yeah, I'll take a shower too so I can wash off whatever.
Yeah. And just call me when you're ready, okay?
Okay, Bob.
Okay, Papa. Love you.
Bye too.
Okay, bye.
Talk to you
Bye-bye.
soon.
Okay, Papa. Bye-bye. Okay, so let's take a look at number one. Um, well, you got integers going from integer to integer. So if I plug in any value for x, any number, I should get a number, a different number. So I think it's both 101 and onto. If you were to do a t-table on it, I believe you would get any number that you pick for your x, you should get a value for y, a different. Yep, it is 1-to-1 and onto. 1-to-1 and onto. So if x is not the y, then so h is 1-to-1. Okay, all right. Second, integer functions going from integer to integer. There's no plus, minus, it's just all integers, negative, positives. 2x. So I can plug in any value for x, but I don't think you're gonna get all the real integers because I think you're only gonna get evens. So I think it's 1-to-1, but not onto. Yep. Any odd, yeah, you're gonna get all even. So it is not onto. Okay, all right, cool. Number three, integer to integer. Okay, so now I have a floor. I can select any value for x. But 2, 3. Let me see. I'm not getting any. Well, you're gonna get a floor, so I don't think you're gonna get. Well, you may get all the integers eventually. So I think it's both 1-to-1 and onto. Let's check it out. No, it's not. So if f is 3, oh, if you plug in 3 for f and you plug in 4 for x, sorry, if you plug in 3 for x and 4 for x, you're going to get 2. So both of those numbers go to 2. So it is not 1-to-1. It's not 1-to-1. But is it onto? Yes, it is onto. Eventually, if you do all the integers for x, you should get all integers for y. Okay, cool. All right, cool, good to know. All right, when the domain and target are finite sets, it is possible to infer information about the relative sizes based on whether the function is 1-to-1 or onto. So here's another little tip. If a function of your domain to your target is onto, then for every element in the target, there's at least one element in the domain. So it's saying that the number of elements in your domain, in order for it to be onto, has to be greater than or equal to the target. Okay, next one. If your function maps your domain to a target and it is 1-to-1, then every element in the domain maps to a unique element in the target. So it's saying if it's 1-to-1, 1-to-1, right? All of these x's get mapped to your target. It is less than or equal to the number of elements in your target. If it's bijection, that is both onto and 1-to-1, then that means the number of elements in your domain, it has to be less than or equal to the number of elements in your target, and the number of elements in your domain has to be greater than or equal to the number of elements in your target. Thus, they have to match. Same elements with the same amount of elements on your target. That's bijection. So that's good to know. That is good to know. So in order for the bijection to occur, you have to have the same number of elements in D with your T. All right. Next, the fact that the domain and target of a bijection have the same size may seem simple, but in fact, it turns out to be extremely powerful. One way to count the elements in a set is to define a bijection between that set and another set whose size is already known. So counting the elements in a set is a fundamental part of discrete probability, which we will discuss later, and it's an important tool in many areas of science. All right, so let's take a look at our participation activity. As you guys recall, we have this notation. We have braces with 0, 1. That's a binary. It has 3 elements of zeros and ones, and whose target is now going to be a 2-character binary. Is it possible that F is 1-to-1? Let's see, 1-to-1. The number of elements in D has to be smaller than the number of elements in, I think it's yes. No, it's wrong. The function has a target with 4 elements and a domain with 8 elements. If F is 1-to-1, then the target must be at least as large as the domain. So it was a no. Okay, so why? All right, so it has, this one has, oh, okay, so it has 3. So you have 0, 0, 0, 0, 1, 0, 1, 0, 0, and okay, 8 elements. Okay, and then you have 1, 1, 0, 1, 0, 1. Let's see, what's the other one? 0, 0, 1, 1, 2, 3, 4, 5, 6. I'm missing 2 more. 0, 1, 1, 7, and what's the other? 1, 1, 1. So your domain has 8. 1, 2, 3, 0, 0, 0, 0, 1, 0, 100, 110, 101, 0, 0, 1, 0, 11, 1, 1, 1. Those are going to get mapped to a 2-character binary. So you only have 0, 1, 0, 0, 1, 0, and 1, 1. Yeah, it's not going to be 1-to-1 because not all of the elements of the 3-character binary gets mapped to a 4. So yeah, this is yeah, it says here that in order for it to be 1-to-1, the number of elements in D have to be smaller than or equal to T. For this one, D has 8, T has 4. 8 is not less than or equal to 4. So yeah, it is a no. Is it possible that F is onto? Yes. I see that one's yes. Yes, because the number of elements in T is smaller than the number of elements in D. There are 8. There are 4. So 8 is greater than or equal to 4. So it is onto. Is it possible that F is a bijection? No, because it's not 101, but it's onto. Is that correct? That is correct. They have to have the same sizes. Again, the number of elements in D is 8. Number of elements in T is 4. They are not the same. So it is not a bijection. All right, cool beans. All right, let's take a look at the challenge activity. It says here to draw an arrow diagram and identify function properties. All right, it says here, if element in f of x does not visibly correspond to a circle x, consider the entire set of integers within the function's domain for corresponding x. If x is a real number, then the absolute value of x is the absolute value of x. Well, I just said that. If A is a finite set, then the absolute value of A refers to the cardinality. Okay, so that is not absolute value. If it's a lowercase letter, it's considered an absolute value. If the variable inside is a capital, it's referred to as a cardinality, a count. Both uses the absolute value symbols that are standard mathematical notation. So that's the difference. Lowercase is absolute, uppercase is cardinality. Good to know. All right, let's start it off. So if my function maps an integer with an integer, I plug in f of x equals x plus 3. I need to map it out. All right, so let's see how this works. Select the element f of x that corresponds to the circle. Okay, so I think if I plug in -2, it goes to 1. -1 goes to 2. 0 is 3. I think that's it. Oh, okay, now what do we do? All right, so 1 goes to 4. Check. Oh, I need a complete B. Hello. Is it 1 to 1? Is it on to? Select the properties that describe f of x. All right, to me, it looks like it is 1 to 1 and okay, oh, I have to do it again. All right, try it again. Oh, it is a 1 to 1 and on 2. That is correct. Yep. All right, next. Okay. Z integers to integer. -1 goes to 2. Okay, -1. That is going to be 1. 0 is 2. 1 is 3. 2 is 4. They want to know, is it 1 and 1 on 2? Yeah, I think it's 1 and 1 and on 2. All right, good. We're doing good. Okay, now let's look at this one. Absolute value of -2 is 2. 2 plus 1 is 3. -1, -1. All right, that's going to be 0. 0 is 1. 1 is 2. 2 is 3. Uh-oh. It looks like it's 1 to 1, but I don't think it's on 2. Oh, what did I do? -1. Oh, a -1 is 2. Hello. All right, try it again. Man, what did I do? I don't know how to think. All right, absolute value of -2 is 2. 2 minus 1 is 1. That's 1. 1 minus 1 is 0. 0 is -1. 2 is 1. Oh, 1, sorry, 1 is 0. 1 is 0. 2 is 1. It is 1 and 1 and not on 2. Oh, that's right. It's not 1-to-1 because 2 and -2 map. That's right. It is okay. Sorry. Let's try it again. Hello. 2 of these values got mapped to my targets, so that would not be on 1-to-1. Okay, sorry. Try it again. -2, that's 0. -1 is -1. 0 is -2. 1 is -1. 2 is 0. It is not 1-to-1. And it is it on 2? Let's see, is it on 2? All of these elements get mapped. I think it's on 2. No, f is not on 2. Okay, so because there is no value of x such that f of x maps to -3. Oh, okay, wait a minute, but this is nothing gets mapped to -3? Huh. -3. That's right, it doesn't. 2, 3, 4. That's true. Okay, let's try it again. All right. -2, that's 4. -1 is 3. 0 is 2. 1 is 3. And 2 is 4. Nope. They go to, okay, so it's not 1-to-1. And it is not on 2 because 0 and 1 is not used up. Check. Correct. All right. These are very interesting. All right, integer to integer. Plug it into my function f absolute value of x plus 1. At -2, it's 3. At -1, it's 2. At 0, it's 1. At 1, it's 2. At 2, it's 3. 2, it's 3, right? 2, it's, yeah. Okay, what did I do? Okay, so I think it said as I'm finished. Okay, so for sure it's not on 2 because these two elements are not, these two are not, it's not on 2. It's not 1-to-1 either because 1 and -1, so it's not 1-to-1. Yep, okay, cool. All right, all right, so we have a floor. Okay, so floor. 3, that's 0.75. 0.75 is 1. 4 is 1. 5 is 1. 6 is 1.5 is 1. 7, 1. 8 is 2. All right, so by the looks of this, it is not 1-to-1 and it is not on 2 because I don't think I have these numbers being used. Uh-oh, what did I do? Oh, jeez. 3 is point, it should have been, yeah, why did I put 0? Is it, oh, it should have been 0. Try it again. All right, 2 is 1. 2 is 1. 3 is 1. 4 is 2. 5 is 2. 6 is 3. Okay, 7 is 3. Okay, it's not on 2 and not 1-to-1. Oh, okay, what am I doing now wrong? F of x is on 2. Why is it on 2? Why is it on 2? Oh, it goes on forever. Is that why these little dots mean it goes on forever? Okay. Yes. Okay, I see. All right. Try it again. 8 is 2. 9 is 3. 10 is 3. 11 is 3. 12 is 4. 13 is 4. Okay. So wait a minute. 3, 10, 11, 12. Okay, so it's not 1-to-1 for sure. I think it's on 2 because it goes on forever. Yep. Okay. Good to know. All right. Next. Yeah, maybe because because of the floor, it could just goes on continuous, right? And we'll eventually get all the numbers. Okay, how about this one? All right, 4. 4 is 5. That's ceiling. 5. 5 is 2. 4 is 2. 5, 6, 6, 3. That's 6. 3 that's 2. 6, 7, 2. 7, 8. 8 is 2. 8, 9. 9 is 3. Yeah. And 9 is 3. 8 is 3, 9 is 3. All right. So it's not 1-to-1, but it is on 2. Yep. All right. Wow. Interesting. Interesting. All right. Very good. So these are good exercises for us to practice our 1-to-1, on-to, and bijection. And so you'll see later on when we do other things, again, make sure that when they're given a function, check to see if there's any restrictions. Because if there are restrictions, you have to delete them from your domain or your range. So just be cautious.